Hello, everybody. This is a Proust question, but it's not a complicated one. Probably one of the easier ones. Congruent triangle methods with sequences of rigid motions. If a sequence of rigid motions is performed, all you need to know is that it means the image is congruent to the original. Whether it is rotations, reflections, translations, if anything with rigid motions is happening, it just means that the image is going to be congruent. Let's talk about our congruent triangle methods. We have side, side, side. We've got angle, angle, side. We've got angle, side, angle. We've got side, angle, side. And we've got HL, which is technically ASS, which only works if it is a right triangle. So let's see what's going on here. And the other thing you have to know is an angle onto an angle proves an angle. That's good. But a point onto a point means nothing. A point onto a point, that does not mean that the angles are congruent. It doesn't lead towards anything. So angle onto an angle, good. Side onto a side, good. Point onto a point is useless. It doesn't do anything. Which statement is sufficient evidence to prove that triangle DEF is congruent to triangle ABC? We can go through each choice. I need one of these 5 pictures. So choice 1, AB is congruent to DE, BC is congruent to EF. That's only 2 things. So nope, I need 3 things to prove triangles are congruent. That one's out. Choice 2, angle D is congruent to angle A, B and E, C and F. There are only 2 combinations of 3 things that don't work, S and A. And this is A, my friends. S and A do not work. Again, the only way that ASS works is if it is a right triangle, in which case it's HL. AAA does not work. It makes similar triangles, but not congruent triangles. There is a sequence of rigid motions that maps AB onto DE. That's good. That counts as a side. BC onto EF. That's good. That counts as a side. And AC onto DF, that's good. That counts as a side. If it's a rigid motion mapping a side onto a side or an angle onto an angle, that's good. That's SSS. That's good. Let's just take a look at the 4th choice. We've got, there is a sequence of rigid motions that maps point A onto point D. That's useless. And angle A into angle D would be good, but point A into point D means nothing. AB onto DE is good. Angle B onto angle E is good. That's only 2 things. If it said angle A onto angle D, then that would be correct. That would be angle side angle, but it's not. Point onto point doesn't give you anything. Choice 3 is your answer. So I need to end up with one of these 5. Again, what doesn't work? AAA doesn't work, and ASS, an angle with 2 sides where this angle is not in between them, does not work unless it's a right triangle, in which case it's HL. So let's just take a look at one more. Drawing a picture will be helpful here. I've got YEG and POM. YEG, POM. It says that angle G is congruent to angle M, so that is set. It says which is sufficient to prove that they're congruent. So again, I need one of those 5 pictures. Angle E and angle O, angle Y and angle P. That's AAA. AAA does not work. It's going to get a little messy here. That's okay. Next choice, YG is congruent to PM. YE is congruent to PO. I do have 3 things, but that is ASS. The angle that's marked is not the angle in between the 2 sides. Angle Y would be the angle in between the 2 sides. That's ASS. That does not work. It's getting too messy. I'm just going to draw them again. Y, E, G, P, O, M. There is a sequence of rigid motions. So again, I have angle G and angle M already. There's a sequence of rigid motions that maps angle E onto angle O. That's good. Angle onto angle is good. And YE onto PO. That is angle, angle, side. And that is good. And let's take a look at choice 4. There is a sequence of rigid motion that maps point Y onto point P. That's nothing. YG onto PM. That's only two things. If it said angle Y onto angle P, that would be good, but it doesn't. A point onto a point means nothing. That's your answer. A point onto a point means nothing. What happened to the... Oh, I'm frozen. An angle onto an angle does. A side onto a side does. That's it. Goodbye.